Hi, Ruben. How are you?
Hi, doing fine. And you?
I'm doing good. Thank you so much for joining us today on this interview, learning a bit more about OR as a vehicle to drive a more efficient world. So for those tuning in, I'm Carlos Zatina. I am an optimization enthusiast. I also delve into product and engineering topics, all combining them together to make a optimization project as successful as possible. I currently do this at Amazon and within the supply chain optimization technologies team. And I have the enormous pleasure to interview my colleague, uh, Dr. Professor Ruben Ruiz Garcia. So I'll briefly read his intro. So Ruben Ruiz is Principal Applied Scientist at Amazon Web Services and full Professor of Statistics and Operations Research on leave of absence at the Polytechnic University of Valencia, Spain. He is co-author of more than 100 papers in international journals and has participated in presentations of more than 200 papers in national and international conferences. He is editor of the Elsevier's JCR listed journal Operations Research Perspectives and co-editor of the JCR listed journal European Journal of Industrial Engineering. He is also associate editor of other journals like Top and member of the editorial boards of several journals, most notably the European Journal of Operational Research and Computers and Operations Research. His research interests include scheduling and routing in real-life scenarios, as well as cloud computing scheduling. Quite a summary, quite a trajectory. A lot of things going on, over 100 papers, and editor in some of the top journals that I have been fortunate enough to publish in. Ruben, thank you so much. I think so. I guess my first question is, you have this strong academic career, and now you've transitioned officially because I believe during your university time you also did consulting as well for enterprises. But now you're officially like on the other side.
Yeah.
You're moved into Amazon. You're part of Amazon Web Services, and essentially what you do impacts in real time thousands of businesses, millions of people around the world. Do you feel that your experience in academia gave you any special advantage or disadvantage in this new role?
Mhm. Well, first of all, thank you very much for having me here. It's a pleasure to try to share some of little bits and of knowledge that we accumulate over the years, and hopefully it's useful for other scientists and practitioners. So, going to your question, being in academia, special advantage or disadvantages in a large company like Amazon? I think both. If you compare my background with the background from somebody that has always been working in industry, I think I have strengths and also weaknesses. Because starting with a former, the advantages is the accumulated knowledge from having worked with other companies doing consulting and having read hundreds and hundreds and hundreds of papers, right? You get a vantage point. Also, being an editor, you get a vantage point where you know everything there is to know to some degree, of course, scientifically speaking. On the other hand, I lack a lot of experience in working in large corporations like company culture or workflows, production code, pipelines, development, all this. Obviously, I'm not as strong as my peers, and that's a disadvantage, of course.
Yeah, there's also in Amazon, there's a lot of the alignment discussion. There's a lot of alignment that needs to be done before getting a problem, even a project started. So I think within that alignment itself is kind of the finding out what is the real problem. Oftentimes people come up and like, so we want to look into this problem space. I feel like, at least in my org, it's been looking at problem spaces, and it's all very ambiguous. It's not like in academia you have a really well-defined problem, you know what the objective function is, you know what the constraints are, and you're just finding a way to optimally or more quickly solve that particular problem. But there's that step, you know, at least in my experience, both in Amazon and in other companies, where it's like, we need to identify the problem. The problem
Yeah.
itself is ambiguous and not well formulated. Could you share with us like how you go about this process of, you know, going from that ambiguous problem statement to something that's like a clear formulation that you can actually put into a computer and solve?
That's a very good question. And in general, in my experience in OR, this is not really an issue because, as you have stated, oh, I'm working on the TSP or I'm working on the BRP with backholes or whatever. Everybody understands that formulation. Everybody knows that problem, right? Well, people working in your field, in your specific part of the field. But when you go to a customer, to a company, they think they know what their problem is and they explain a little bit, but there are many sharp edges and there are many ambiguities and things that are not known, right? So in my experience, you need to write documents and you have to iterate through those documents. And you share the documents with the customer, and those documents need to be written in the language of the customer. This is what the system is going to produce. And this is what you're going to be doing with what the system is producing. And then the customer will tell you, no, that's not exactly how I want to go about it. And then you learn a little bit more about the problem they want to solve and you iterate, right? So
Yeah.
through this writing, all these ambiguities are detected and addressed. And you should jump to the formulation only when the customer understands exactly what the model is going to be doing, the workflow end to end, and the customer has agreed that that is the thing you want to solve, right? And then you start modeling.
Yeah.
And 80%
And
of the work is already done because the
exactly.
modeling part is not that difficult once you address all that.
That's exactly what I was gonna say. I think we're at least in my training, like we're highly trained in once that problem formulation is there, like multiple, a million and one techniques to, you know, try to solve it, optimality or whatever, heuristically, et cetera, et cetera. And I don't know if it's a fruit of that in actual industrial projects, that becomes like the easy part, rather than the actual problem, you know, scoping and definition. But definitely, I feel like you hit the nail on the head. Once that problem is formulated, writing a prototype, writing a code, and putting it into production becomes the simpler part. What I don't know is if that's because the way we're trained, or if that in general is how these things would happen when you're doing, you know, industrial projects. So that leads me to like the next question. Do you think like the OR programs at universities could do something better to kind of train in this initial problem scoping phase? Like what things do you think could help for that to be a little less painful for an OR scientist when he runs into it when they run into it for the first time?
Yeah, I think there's definitely room for improvement. I have been teaching OR, well, not in the last few years, but I was teaching OR for more than 20 years. And, you know, we always introduce OR, oh, this is a really nice, very important, this is cross-disciplinary, affects all companies. And then you have a step of problem definition, and then you have problem formulation, blah, blah, blah. You explain then the process, and then you jump into modeling, right? These are the variables, these are the objectives. And somehow the problem is defined, right? And then you go and in class and in the exams, you give them a problem statement. Well, I wish our customers will give us a problem statement, right?
I'd say, yeah.
And that's really not the case. And we are doing it backwards because, and then we go into the simplex and branch and band, and we explain all these technical things to our students, but we are doing the other way around. No. I think we should start in teaching with the first part of the decision-making process. This is how to go from a very vague problem definition to a clear and precise problem statement that needs to be solved with all the iterations involved, because sometimes the customer asks you to solve things that are not solvable or the customer doesn't really have that data, or getting that data will be very expensive. So you have to guide also the customer into a compromise that you can solve, right? So
Yeah. It's
that
also a
part,
negotiation process, right?
it
Like,
is.
yeah.
It's in some regards, it's a negotiation process, because then there's the budget. If the customer doesn't have the budget for the thing the customer wants to do, then you have to compromise.
Yeah.
We never teach our students how to do that process.
Yeah. Yeah. I think it's, I think like OR itself is kind of, it's been so focused within an engineering and technical scope that, you know, that part gets kind of overlooked. And it leads me to like to wonder like, would OR would an OR program be better suited within a business school or with more interaction with, you know, business courses? What do you think about that?
Uh, my opinion is contentious. I think OR should be in business schools.
Okay. I
And
mean,
the focus should not be that much on the methods we use to solve the OR problems, because the methods are implemented in the solvers, and
yeah,
you can just use the solver. Well, it's a specialized piece of software, but you don't need to know how to iterate the simplex by hand in order to solve OR problems. So I think there is much more of business and psychology and
mm,
soft skills in OR that most people think they are.
yeah, yeah. I 100% agree with that. Like, I think going back to the point on universities, for example, one of the um, top programs in Carnegie Mellon is, I believe, within a business school itself. So I don't think it's a far-fetched idea. I do see implementations of it, but it's definitely not widespread. And I think like we should like as we take a step back, like should reconfigure, you know, what our mental model is about, you know, where this should live. Because that's a problem with these cross-disciplinary fields, right? It's hard to know where to place it because there's the other component as well, right? I mean, at the end of the day, we develop software or we contribute toward the development of a software. Should That's a good case for that to be within engineering, and it's also a good case for us to be for OR scientists to have a lot more software engineering experience or coding. I remember I learned Git when I landed at a company and they told me, "Why do you have 10,000 folders with different versions? This is not how you do things." And I was like, I felt like the stupidest person in the world, but it's the reality. Like I wasn't trained in terms of software development, version control, things like that. So yeah, hopefully like it's a hard question to answer, and there will be multiple contentious views because there's no clear one answer. You know, it's kind of like the child that has multiple, you know, places where it could fit. But I think it's something that like at least from our side we should be thinking about. Now, you mentioned something that also resonated with me, and I think within the LinkedIn community this has surfaced quite a bit. You mentioned and you mentioned it actually in a piece in the Spanish OR Society's bulletin that let me see if I remember how it was. So you made the analogy of OR being a vehicle, and in the use case of a vehicle, we use a vehicle, but we don't. All drivers don't know the interior mechanics of either a combustion engine nor a nor how the brakes work or anything like that. And we don't need to know to be able to
Mhm.
operate that machine. So, and I think like the comparison here of knowing the internals of the engine are really, you mentioned we're like doing the simplex method, learning to implement branch and bound. I mean, I haven't implemented the simplex method myself, re-implemented it or anything, and I don't think I've ever do that uh, on my side. But following up on that analogy of the vehicle, what do you think would be learning to steer, learning to brake, learning to shift for us to actually drive this OR vehicle into, you know, applications that lead to a more efficient world?
Yeah, it's a very, very nice analogy. I use it a lot, right?
Yeah.
Because, I have a car, I sit in the car, I hit a button and it's on.
Yeah.
I've been taught how to drive. I don't need to know how the internal combustion engine works in order to drive, right?
Mm.
And most drivers don't need that to drive. So this is the analogy also with OR. You don't need to know the engine to do OR. Obviously, if you're doing OR at a very high level and you're proposing new methodologies, sure, you need to do that, but not to apply OR in industry. So for example, the brakes. And this follows the previous discussion about knowing what problem to solve, right? In OR, we jump too quickly to the model. So we should be hitting the brakes whenever we see a gap between what we're doing and what the customer perceives is going to receive from what we're doing. Because we want the project to be successful. We want the project to hit the deadline and to hit the budget. You don't want to be over budget or over the deadline, because those things are much more important than optimality or whatever,
Yeah.
right? We need to give the correct solution to the customer. So hit the brakes, go back to your problem assumptions and simplifications. If you see that you are not providing the solution or the customer is not really satisfied with the compromises you're doing, right? Similarly, steering wheel and the signals is the solution representation. We never talk too much about the solution representation, right? In OR, we present values of the variables and we're done. That's not a solution representation. You have to present the solution in the language of the customer and the company where this is going to operate. You need to integrate with systems. You need to add KPIs, alarming, canaries, everything, so that the solution is perfectly integrated within the customer system. Otherwise, they're not going to use it. Who's going to be looking at a list of variable values, right? That's pretty obvious, but we never discuss this. And not any solution representation is going to be as good, right?
Yeah. And I think also, like, I've seen this also multiple times. So like when you're asked like what is the insight, you get like just like a whole bunch of executions and their respective solutions, including the like auxiliary variables you use to capture some other dynamics. Like we don't like, that's not even the decision you're making. You're just doing an approximation of downstream what impact it could potentially have. But the decision point you're making are just these particular variables. They're often a much smaller subset of the entire formulation that you're putting in, you're trying to solve. And I feel like that you're 100% correct. Like that gets lost. Like it just becomes, solution time, optimality gap. The customer doesn't care about that. They care about how does this impact my actual business outcome. And that in itself is hard to quantify. And I feel there's also like multiple ways to do that. So, which leads me to my next question. So, how do you approach, so let's say you already have your OR problem, it's a nice formulation, clean formulation, clearly defined. I mean, once you get to that point, there's more than one way that you can actually like get to a solution. For example, recently Irv Lustig shared a take on his approach, which is data first, model second. So essentially what he does is they do an initial EDA where they're pulling the customer data, they're looking at the trends, and that sort of drives the next step of getting the ball rolling. How do you approach this in your day-to-day right now at AWS?
That's a very good question. Data first, model second is something that is very obvious when you say about it, but we don't tend to do that. We assume the data is given, and that's actually never true. Every single time I have approached a problem with an industry, they tend to tell me, the customer tends to tell me, oh, we have all the data. No, you don't. You don't even know the data I'm going to be asking for. And if it's the first time you're doing optimization, you're not even aware of the amount of data we have to put inside a model to make it work. That means that your first models have to be very coarse approximations that give some solutions with existing data, because you have to start the ball rolling. if you ask the customer, oh, before we do anything, this is 2 years of work you have to do to get all this data, you're dead. You're dead. That's not going to happen. However, okay, this data is not perfect. We're going to be needing down the road more data, but this is what I can do with the data you have right now. And then you add value and you give value with what you have. And then you earn tokens to continue working with that customer with new data, model extensions, and so on.
Yeah.
So this tendency of having the perfect model in the first shot is completely nonsense.
Yeah. It's more of an iterative process. I think,
yes,
like you mentioned, the iterative process from the beginning, when you're even scoping the business problem, that dynamic also translates not just within that, part of the project, but the project itself, right? It should be along the lines of, okay, here's an initial solution with what we have. Here are some simplifying assumptions, deployed, and then, monitor, and then, rinse, repeat. And
yeah, and even sometimes, this is this adage that the customer is always right, but that's not true. Sometimes the customer wants to solve things and they don't anticipate problems they're going to have because they don't have the optimization experience. I did, for example, lots of production scheduling, and one of the main cases in which production scheduling fails is when the production planning is not well solved. And I have been in many companies where they didn't really have a robust planning, production planning, which is long-term. Long-term in production is 6 weeks, 8 weeks, something like that. So if you solve very well a production scheduling, which is the day-to-day scheduling problem, with a very bad planning, the outcome is going to be complete garbage for the company. So many cases, I had to talk the customer into, hey, I know you called me to solve this problem, but this is not the problem you're not solving. And you're just going to aggravate the problem you're not solving, right? Same with routing. Sometimes, I have all these routes I want to make, and then there is a big problem with the customer distribution between the routes, or the driver's assignment to the trucks is not balanced. So you have to start very small, not with the complex models first. And sometimes you have to approach the problems you're trying to solve completely differently from what initially you thought you had to.
Yeah. You have to be more open, I guess, is like, there's, I 100%.
More like a consultant, right? And specialty consultant, but you have to be very honest with the customer. If I solve this problem, you're going to have these other problems down the road.
Yeah, 100% get you. So following up the customer, since we're discussing customers, and we are at a company that is customer obsessed as well. Like, recently, with the whole Gen AI progress and all the hype, and even like if you look back a few years, there was this huge hype on reinforcement learning, with AlphaGo, etc. At that time, I was like finishing up my PhD more or less, and starting to get into a company. And a lot of the things that we would get were like, I want to apply machine learning. Like all the use cases were centered around machine learning because the customers wanted machine learning. All the executives were like so excited about this new initiative. And I feel that's the same case right now for Gen AI. Do you think companies are still right now excited about OR projects comparable to, Gen AI, machine learning, these other fields?
No, profound no. It's sad, but this is the way it is. Actually, I don't think companies have ever been really excited about operational research. As a matter of fact, most companies do not even know what OR is. I did consulting for lots of companies for many years, and almost every single time I had to explain what OR was because they didn't know it. They just didn't know. And I think this is a result of corollary of OR being too academic. And not being customer obsessed and not centering the customer, right? Whereas artificial intelligence has always been about the applications, right?
Yeah.
Always been of the application. Nobody goes and explains the algorithms that go inside. No, they do a chatbot. And the chatbot is very easy to use. You just talk to it. We don't do that in OR. And companies don't know what OR is. And the ones that do, they think it's outdated, out of fashion, something from the 80s.
Yeah, yeah, yeah. Do you think so? Yeah, well, I guess my takeaway from your response is the focus more on applications that can be easily interacted, like the user can easily interact with, having it more openly displayed as well. But it also got me thinking about another potential problem, right? Like operations research isn't exactly a sexy name, right? Machine learning is like you can imagine like a box, a computer with taking notes, reinforcement learning, generative AI. These names have more I don't know, they're more palpable. They have some appeal to it, and they've done a great job of, like you said, they focus on the applications and they're consistently like publishing content, information, white papers, all very openly. Like I think that's also a key for what they've done. Do you think we as OR have a marketing problem as well, in terms of maybe choosing a different name, a new platform? What are your thoughts on that?
Most definitely we do. I mean, only Informed has tried twice already to rebrand OR. Some years ago, they went on with a big campaign, Signs of Better.
Mhm.
That's what they tried to rebrand it. And now they more or less jump on the bandwagon of AI, and they're referring to OR as analytics.
Mhm.
So, and other societies have tried to rebrand it. I think we have a marketing problem. But just go on YouTube, you look for deep neural networks, reinforcement learning, and you find entire channels.
Yeah.
You look for something OR, and you find a guy doing simplex iterations on
Yeah.
the screen, right? So
Yeah. Yeah.
there's
Yeah.
a lot of work for us to do if we want to put OR on the map. I
Yeah.
don't think we have to invent anything. We just have to get ourselves to do it.
Yeah. I completely agree. I get you. I get you. I get you. So I'm gonna go back, switch back into like the industry projects itself, because this is like what we want to focus on as well. But I really appreciate your perspective, and very insightful way of thinking of our field and the future of our field. So one of the things I also think is helpful, or I had trouble with when I started, was like I had no idea what an actual optimization project look like in terms of like a tech stack. Like what tools do we use? All I knew to use was Cplex through a C API, which, I don't wish that on anyone. But there are other, ways to get the ball rolling and, build prototypes, etc. So what does your tech stack look like right now at AWS?
Well, at AWS right now, we obviously have Git, which is the tool we use for version control. Then we basically use a mixture of Java and Python to develop.
Good.
There is a lot of code review. For those not knowing, is you code something and then you publish it, and some peers in your teams or assistant teams review the code, and then we go through revisions. And when the code is approved, we merge it, and then we have all kinds of tools in order to go from code that is being tested to code that is in production and can take weeks. So as for modeling, I'm not very keen on using intermediate layers
Mhm.
in between the solver and the programming language. I think there's still opportunity for those tools. The problem with those tools is that they add latency.
Yeah.
For example, when you use GAMS or AMPL or algebraic language, it is easier than to go directly to the solver API, and you are actually solver agnostic, right?
Mm.
But the problem with those tools is that you are missing out the specific features from each solver. And that sometimes those features are key for performance, and then you have a huge performance problem when you're trying to solve large-scale problems. So the fewer the layers, the faster you're going to develop. So if you're dealing with large-scale problems, and in AWS, the problems are very big, you need all the performance you can get. So But it depends on the use case, right? If you're working for a smaller customer and the problem is not as big, I will be probably using an algebraic language or a very nice intermediate layer like Piomo, where you can very easily define a model, right? And solve it right away.
Yeah, I get you. Yeah, I think my experience also resonates with that as well, especially with the small and medium-sized companies.
Mhm.
They don't often have the budget, or it comes to them as a surprise that, we would get such an expensive solver that they have to pay over 20K a year to maintain. And, tying the language to that solver is like a huge commitment for them. And so at least from my experience, like we try to make it solver agnostic for these smaller companies, because then you can just plug and play. You can use, open source solvers like CBC, Skip, etc. And then that's a huge like load off their budget of 26K for a small company is a lot, on that topic. Do you feel the commercialization of solvers also has potentially contributed to, the proliferation of OR, especially in these small and medium companies? And if so, like, what do you think we could do? Should we contribute more to open source solvers? What have been your workarounds when you worked with small and medium-sized companies?
Yeah, this is a legitimate concern. I had quotes from IBM for Cplex in the hundreds of thousands of euros per year.
Wow.
For medium businesses, which was a complete blocker, right? Yeah, I think this is a chicken and egg problem. The reality is that not that many companies use solvers. We think in OR that this is ubiquitous and every company uses OR, and the reality is that it is not such a large customer base for the solver companies. So they have to charge these prices because they are not selling the solver to that many people. So if we break this business cycle in which OR is too academic, is too sophisticated, and we make it more accessible for all businesses, we will have more businesses buying solver licenses. And therefore, the price for each license will decrease because it will be a larger customer base, right? This is not just my opinion. There was a session in the last Euro conference, and there was Express, Gurobi, Exali, and that's what they were saying, that they don't have that many customers. Gurobi doesn't have that many customers. And if you look, they have all their people in their website. It's not a 10,000 people company. It's actually rather a small company. So this is a problem. If you have 20 customers, well, the licenses are going to be expensive. And that is a vicious cycle. So
yeah.
Sadly, in my experience, for large problems, the open source solvers are really, really, really behind the state of the art solver. So I'm not so confident that open source software is a solution here.
Okay.
Solvers are complex and specialized, and who's going to make them for completely for free? I mean,
so maybe increasing the pie rather than, having amongst them competing for a slightly larger piece. Let's increase the pie. Let's make it more real, more applicable, and then we'll have less friction to start these optimization projects. So just to wrap up our very insightful interview, I'd like to close it with one last question. So say someone with no formal OR training showing interest in jumping into this field, becoming an OR consultant, applying OR as a vehicle for a more efficient world. What references and tools would you recommend that they learn and become proficient in to be successful in this field?
That's a very interesting question. People will say, "Oh, read the books about all the methods and so on," but I'm going to go with the tangent and with the theme of the interview. I think, of course, some coding is essential because you ultimately have to code the solution and provide the software, right? Because that's what we're going to be providing, a software. But I will dip into psychology a little bit, negotiation skills, active listening, bargaining, because of this thing we were mentioning during the interview of going from very loose, vague, and often contradictory requirements to a very simple solution that the customer is going to be using. Simple, easy to maintain, easy to evolve, and effective, right?
Yeah.
Not so much about optimal or very sophisticated model, something simple. So I would say, yeah, you're gonna need coding, but I'll say you could be also very successful by complementing all that knowledge with some psychology and soft skills.
Yeah, those soft skills become hard skills eventually. Like those are the ones that I think oftentimes are overlooked, but can make a big difference in the end. I think one of the things also that myself I feel like I was missing in my training was, you know, modeling itself. So there are multiple ways to approaching this modeling. And you know, like I learned to do MIPS. That's kind of what I was dedicated to do. Um, any good recommendations for modeling? Any references, any framework that you would recommend for someone, you know, looking to jump into this field?
I recommend Operation Research and Modeling Approach book by
Okay.
Hazard. It's a very applied book where a little bit of what we are mentioning is mentioned in the book and doesn't go into the methods. It just goes about modeling.
Mm-hmm.
Modeling is, I don't think it's as difficult as people think it is. You just start with very simple assignment problem or a scheduling problem, very simple things, and then you build from those. And
Mm-hmm.
the different constructs we use for modeling in industrial settings are not that sophisticated, at
Yeah.
least not as sophisticated as the kind of things you need to do in journals, right?
Yeah.
If you want to publish in competitive journals, you really have to go very fancy with the methodology, but that's not the case for industrial settings.
Yeah.
Actually, you should be doing those very sophisticated things in industrial settings, right?
Mm.
So I don't think modeling is that hard to learn, actually, compared
Okay.
to the other soft skills that those are harder, in my
Yeah.
opinion. Well, this is all
Yeah.
my opinion, of course.
Yeah. Also, those soft skills require experience, right, as well. So you kind of learn those on the fly as well. Like there's some theoretical background that's good to know, but like I've learned those on the fly. And they make a difference. They make a huge difference. Ruben, thank you so much for your time, for all your insightful responses. Um, we have a lot of important things that were touched, and I think there's still some other important things that we can, you know, touch even more. So hopefully, you know, this is the first of many other interviews with, you know, um, thought leaders in the OR practice, because I think that's something that we are currently missing. But I appreciate you being the pioneer in this endeavor, and thank you so much for your time and for your support.
Well, thanks to you for this initiative. The pleasure is absolutely mine. It's in the best of my interest to propel OR forward.
Yeah,
Thank you
thank
very
you.
much.
Thank you. Have a good one. Perfect.
Bye.
Bye.